Welcome back. We will continue the live lab. In the previous lab, we came up to in the previous part of this lab, we came up to a point where we deployed the main components that build up essentially as clusters, infrastructure, starting with CSI driver, the networking components from Ingress, MetalLB, cluster autoscaler, metric server, Grafana, Prometheus, and the Kubernetes dashboard. One point where we were stuck, or not stuck, where we got challenged a little, you would have seen a snip, is the Grafana instance. Ingress did not give us the right page. I mean, Grafana 2 was not working. So I think it was a copy-paste error from my side. I acknowledge it. I just edited the Ingress definition to have the right host. And we have basically both the Grafanas up and running. Before we continue, I'll just show them to you. So we have Grafana 1, M1, and Grafana M2. So both are now working. Now, in this particular section, what we are going to do is to start deploying workloads. Workloads could be your primary applications or contextual workloads which help your application in some way. Okay, that's going to be the starting point for us, picking one very important contextual application or a workload, which is secrets management as a service. Let's say that, right? In the world of Kubernetes, secrets are sprayed all across, and I think it's implicit that we deal with these secrets and their nuances in a very comprehensive way. That's where Vault comes into play, right? Vault from HashiCorp. There are other providers, but I particularly like Vault from its adoption standpoint and all that. And what Apps Code has done with Vault is what we are going to talk about here. So Tamal, thoughts from you on what KubeVault is, what capabilities does it provide? Please go ahead.
Yeah, I mean, as you already mentioned, right? Like if you're on Kubernetes, secret management can become challenging because there are like so many secrets everywhere. So Vault is a great project. I mean, it's very widely adopted and used. So what we have done with KubeVault is, if you look at the official Vault, it provides a CLI and then an API to interact with it. But when you are running inside a Kubernetes environment, obviously there are two aspects, right? How do you provision a Vault server with a high availability setup with maybe raft storage backend, then like things around, this interactions that you can do with CLI or like an API. Obviously, it gets a bit challenging when you are in this kind of, declarative environment. So what we have done is we have created this CRD-based interface, you can say, to this Vault. So you can provision the Vault as a first step, and then you can kind of, enable the secret engines. So you can, and then the auth methods, right? So you can actually get it to work with the Kubernetes as the auth method. So the service accounts can interact with this Vault. And then again, the secret engine. So essentially, let's say when you are running these databases, you can, configure sort of necessary permissions and turn on those secrets and connect Vault to those database engines with credentials, all of those through sort of the YAML or like a CRD. So that way, everything can be declarative, right? So you can live within your like a kubectl or Helm type of environment and just do everything from there, right? So that's kind of what Vault provides, KubeVault provides, and it makes Vault cloud native, declaratively interactable with inside a Kubernetes environment.
Fantastic. So now, what's exciting about this lab is if you glance through most exhibits or samples on the internet sites, you will typically find, and I found it challenging equally, right? When I went on to building this scenario, a distributed environment where you have a Vault server, which is centralized, let's say, and not co-resident on the same cluster on which your applications are running. Generally, most of the blogs or articles or whatnot are written as where you have the Vault running, either through the Vault operator or through, any other means. And then the apps are also running on the same cluster, and then you typically kind of, start. And it's not very clear. So we've intentionally built this as a spread out architecture where M1 will be hosting the Vault server. M2 is what the Vault clients will be. And in these cases, they are going to be our database secrets, which are essentially consumed by KubeDB to authenticate for database connections. And these will be retrieved from Vault. Again, KubeDB will rely or is extensible in the sense that KubeDB provisions the database, and then it can either provision the secrets themselves or rely on third party like Vault, but through mediated transactions like secrets, CSI, or external secrets. Or in this case, we are going to bring HashiCorp's own solution, which is called as Vault Secrets Operator. And the beauty of this secrets operator is that secrets are not static. As per security best practices, you're going to rotate these secrets. And when these secrets rotate, the secrets operator, which will fetch the secrets, has to dynamically sync these secrets onto the applications. And this I'm not going to get too deep dive here, but we will show a practical demonstration of how this architecture actually works on a distributed cluster or a multi-cluster environment actually. Okay. Now we will get into that, but what we will first do, we will be on our M1 cluster and we will deploy KubeVault, which is from AppScore, as an operator. By deploying this operator, we get the ability to create a Vault server as an instance of a CRD. Okay, it's a very simple template. Put in the template, your Vault server will come up. And not a flimsy Vault server, but a highly available enterprise grade replicated Vault with backend storage and persistence and backup capabilities and everything that out there. Okay. For now, I'm going to just start with, now this is an interesting piece, AppScore, and Tamal, I think you should be talking about it, the licensing strategy of AppScore. How do your product license, community, enterprise? What is it?
Sure. Yeah. So we started working on these products. In the very beginning, we were kind of quite a bit open source and just giving it free, kind of like the product-led growth, all that model. But eventually, we found ourselves at a place where we have to actually build a product, right? Like a product that people can buy. So we can build a business and all that. So we ended up as a place where now, if you want to try our products, we offered a free 30-day trial. So you can, try all the features of any product 30-day for free. And the license acquisition process is actually, there's a website, you can go just, click a few buttons, get an email to the license email to you, or you can also automate the process, which is what we're going to do here. And this is actually works out, at least in our experience very well, because if you are even for paid customers, like if you just want to have a quick like a test environment, you can get a free trial license, try things, don't have to talk to us, don't have to worry about payments and all that. Just use it, right? As long as if you are into production deployment where you are running it more than 30 days, that's when you need to reach out to us, and we can work with you as a customer to figure out how what payments and all that, right?
Fantastic. And the best part, I like, you mentioned your website, and I think this is where I really like this. I mean, the structure of your website, and I think documentation in today's world and with the high appeal of user experience, slightly swaying away from this for a couple of seconds, but if I look at the styling of your website, it's really modern, number one. Number two is that it's very clear as to what you have to offer, and then the subsections in terms of, let's say, go to KubeDB. I think it's so clear in terms of documentation, what all databases are you there. So documentation, the whole approach to the various releases, the guides that are available, and the API references. I think it's tremendous to see what you have built as a team, and then how you are keeping it up. to create a user experience which is easier for consumption of your products, right? So again, a big thanks there from the community, I would say, Tamal, including myself.
Thank you. Thank you. Much appreciated.
So what I'm going to do here is I'm going to be on cluster 1. I will also need a license. Not that Kamal is my friend who will give everything for free, but I will retrieve the license, and I'll tell you how to do that. There is a documented procedure on apps code for individual products. I'm just automating a part of it basically, okay? So let's get the cluster UID. That's very important. Licenses are per cluster by virtue of their UID, and every license is tied to a cluster in that sense actually. Okay, so I'm going to go to cluster M1, and I will just make sure that I'm on M1 so that I don't deploy things on the wrong cluster. So we are on M1. Okay, and I'm going to export the cluster UID as a variable, and I've switched to the directory called as KubeVault basically. Okay, and then from here, I'm going to I have in my profile a apps code API token, which is exported as a variable. How do you get this token? Is you can just register for this token on the website and things like that. I've exported it. And what I'm going to do is basically do a API call. Okay. I'm going to do this API call, and the result of that API call along with my cluster UID and the token code, I'm going to retrieve the license for the product KubeVault and put it into a license key.txt file. So let's do this here. Okay, sorry. Am I on M1 or sorry? I have echo dollar cluster name. Cluster names. Sorry about that. Because I'm working with two clusters, my profile's cluster name has changed to, let me just switch my cluster context back to M1 and retrieve this particular, sorry, I'll not source my profile again. I will just take the API call and grab it here. Okay, so we should have now in our cluster a directory called as KubeVault, and inside of that is the license key, which will be used to create the operator instance. Okay, so we are already on one. Sorry, go ahead.
Yeah, and one thing I wanted to add is, like, one of the things that we did when we designed this licensing process was that once you have the license file, which is actually a PKI public certificate, so we have our kind of own internal CA that we use to sign these certificates. So you don't really need any internal access after that. So if you are an on-prem or air-gapped, like a high security environment, you are safe. You can get the license key in your email or some other computer and just take it on a pen drive and stick it in, and that's how it can work, right? So that's the other thing. It's all offline.
I've also seen interestingly a newer solution for you for large-scale deployments, the offline bundle server, which you can manage to manage your licenses. I think that's also there, right? Or is it there?
Yes. So there is another option where you can, it can. I mean, if you have a, you can also do that, right? Where you can plug in, like, if you have multiple certificates for multiple products, you can just plug it in one place, and then individual products will not need to worry about. It will automatically pull from that single place, basically. Yeah,
I like it. I mean, So we have deployed the license or created the license key. We will go ahead and deploy the operator as such, which is the KubeVault operator. And we are setting the license here with a reference to this license key. And I have also enabled the debug option just to see that what's going on, but let it continue, So there's a lot of verification that will happen in terms of, everything is installed, is it ready, not ready, blah, blah, blah. So let's give it about 20 seconds or 30 seconds actually for the, the pods to be ready actually. Okay. Let me pause the video while it's done. Okay, so we can see that the whole CRDs are installed as a part of the operator, okay? And we can just check if the pods are indeed running as per the logs. So we can see that the operator pod is running, it's ready for consumption. And what you can see also here, a lot of good, I would say, automation with regards to how the unsealing process, it's all a little complicated, right? Because Vault is such a important aspect of your security governance. There's a lot that goes on, and Apps Code has been able to, with KubeVault, try to simplify a lot of things where the user doesn't have to deal with the pains of all that. We will see that in practical experience here, basically. Now, what we need to do is, now I will, by virtue of this procedure, still go ahead and copy this command, but it will error out saying the version is, this is another CRD called as Vault Server version. And, I will still run this as a CRD, but you can see here, this is particular, it has already been deployed here. So it says, right, it already exists basically. So I think the newer code or the operator code already deploys this particular server version. Next, we will create the certificate and secret for the Vault servers, okay? And this is basically what the Vault will use, a particular instance of a Vault server will use as a secret actually. So we will go ahead and create the CA certificate and then an issuer for that certificate, because these will be all self-signed certificates. So let's create this issuer. And this is all declarative, right? I mean, I'm just creating the issuer here. Now that the issuer has been created, I will create time to deploy the Vault server. And I will just go through it in a quick, 5-second what it's saying. You can see the CRD is basically of the kind Vault server. So it will instantiate. Now I can do either a HA deployment proper, or if I just want to do a single replica, I have also documented it here in a non-HA mode. Who cares about non-HA mode? Let's go for the HA mode so that we can demonstrate some of the capabilities. So Vault server is the CRD reference. The issuer is basically certmanager.io, and this is the name of the issuer we just created. The certificate that we created, Vault server certs. And again, because I am going to be accessing this particular UI of the Vault through some of my own custom DNS internal, I can supply the DNS names here as a part of the CRD configuration so that my certificate generation becomes less painful, right? And I can accommodate whatever it's required. Otherwise, it's all kind of tethered differently. And then, you create certificate, you do this, you do that. It's very simple. And because it's a CRD in a templated, opinionated format, I can just put it into a GitHub or a GitLab, pair it up with Argo CD, and there you go. Secrets management as a service. You can spin up Vault servers in a very repetitive fashion without worrying about or boredom of these manual tasks and all that. Who cares about, in the new dawn, it's all about automation. So build a pipeline. Let's say you are a security team And your only job is to create Vault servers on the fly. There you have it. You get your Vault servers. Now, allowed secret engines, you can specify if you want to ring fence a particular secret engine, or here I am basically just keeping it blank, and I can say that allow from all namespaces or restricted to a specific namespace. Number of replicas for the Vault server. What is the backend here? So the raft, very important. What we are going to do is this raft backend is going to be persisted with PowerFlex storage class. Okay, so PowerFlex storage class. So it's time to see the PowerFlex UI before we start progressing on this. I'm going to my web portal of the PowerFlex. Okay, it's a very intuitive UI and a very modern look, easy to evaluate things. So I'm going to look at volumes to start with. As of now, you can see I have some from the previous scenarios, interestingly 5 volumes which are there. Don't worry about what they are. This is not with regards to this exhibit. They are previously 5 volumes. Now, let's go back here. So we are going to create 3 replicas. Each one of them will have a PVC, which will be persisted through this particular PowerFlex CSI, which will show up there. For now, I'm just keeping it as 1 gig. You can increase the size if you require. Again, the unsealer, and then the mode, the secret name for that, Vault keys. Okay, so all that is set up now. We will take this particular template and paste it on my M1 cluster. Okay, with a single click, if you understand Vault, you worked with Vault, you know the pains. Here I have a template build out, an operator which is watching out for me, taking care of my Vault requirements. And then I just deployed this template and the Vault server should be coming up. Let's see how we can. Now, what is the name of the Vault server we have given? It's named as Vault. Now, I could have said Tamal's Vault or Amar's Vault. We've just kept it as Vault. It's in a namespace called as Vault servers. So let's go and see kubectl get. Generally, all deployments come with pod, but because it's CRD, I can simply say kubectl get Vault servers minus the namespace wherever I have deployed. So in this case, I've kept intentionally the namespace also as Vault-servers. You can see that the status is initializing, okay? And the number of replicas are 3. The name of the Vault server will be Vault. Now, if I go and say kubectl get pods in the namespace Vault servers, so you can see that it's all coming up nicely. The Vault 0, the first replica has come up. Vault 1 has come up. It's yet not in a ready state. It is getting done. Let's see a quick. So you can see now it's also gone into a ready state. And third Vault is coming up. Let it come up. And while this happens, we will also see get PVC minus n Vault servers. So there should be 3 persistent volumes. You can see data Vault 0, data Vault 1, and data Vault 2. Storage classes PowerFlex, which means if I go to my PowerFlex here, you can see that the count, which was earlier till here, 5 volumes, is now incremented by 3 volumes, and 8 volumes have come up. Now, interestingly, there is a way in our CSI drivers to prefix the volumes with whatever you want. So I've designed a simple prefix which will just label the volume with the cluster name. So M1 is our cluster name. I can do more interesting things, but I've kept it simple. So at least I know that these three volumes, M1, 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 volume ID, they belong to our cluster. And these are the three volumes that are created for Data Vault 0, Data Vault 1, and Data Vault 2. Okay. Now let's quickly see if all our pods are ready. So you can see the three pods which are up and running. Let's also see the status of the Vault server itself. I mean the CRD as such. So you can see from an initializing state, it has gone into a ready state. Ready state means it's unsealed, right, Kamal?
It's unsealed and ready for consumption. Yep.
Ready for consumption. Now, ready for consumption. Now, what's the next logical thing? Defining policies, roles, right? And like Kamal said, you don't have to do this manually like a Vault CLI. You can express these policy statements, roles, and things like that in a declarative sense of a YAML also. But let's say if you've been working with Vault and you want some compatibility to how you have been working and not completely disrupt. Now, while that, you can go to the KubeVault website and understand how a policy YAML looks like. It's very easy, like how we define the Vault server. It's just a YAML going in. We will use the classic Vault CLI method so that we can, experience the best of both worlds. Let's go and grab certain commands from here. Okay, before that, let me also define the ingress for the KubeVault. Okay, the Vault is running at port internally at 8200. We will express it through a SSL connection. So we will take the ingress definition and put it here. And if I look at the ingress, minus n KubeVault, minus n Vault servers, it's still the host will be KubeVault, the cloudgarage.com. The webhook or the external IP is still being retrieved. So we'll give it a couple of seconds more before it comes up. While that happens, we will get the secrets for the Vault server so that we can communicate with the Vault server through the Vault CLI. So let's do this. I'm going to get the secrets as a CRT and key. And I can see that the CA-CRT is there, which we use to create the Vault keys. This is the issuer. This is my license key. And now the secrets here, TLS, CRT, and key. Now, let's see if the ingress has come up. So this host is now advertised through .56, which is the Nginx ingress controller. And if I browse to https KubeVault cloudgarage.com, you can see that I'm already onto Vault. Now, I will not go into the details here. We can do multiple things. I can also connect it with my OIDC provider, whatever. Right now, it's Vault, basically. And there are ways of doing this. So for now, we will start configuring Vault. So I need the Vault CLI, which I already have installed. If not, these are the commands. We will have to export certain variables for my Vault connection, which is the address of the Vault, the cluster UID, the base64, the Vault token basically, and then the certificate that I will use to actually connect to the Vault server. So let me just export them as variables. Okay. I have the variables in play right now. And then what I'm going to do is I'm going to enable this particular path, put my username as root and password as, let's say, fake password. Now, these are the credentials that we will be using for our MySQL server, MongoDB. There are 3 different databases of MongoDB: UserDB, CardsDB, and OrdersDB. And MySQL is the catalog DB, plus also for the Redis, which is for the session DB. So multiple databases, Redis, Mongo, and MySQL. All of them, I mean, for simplicity of the demo, I've kept them up as root and fake password. Now we are going to put this as the vault secrets. Now this is all standard vault stuff. Write a policy and the role and things like that. Okay, so let's do this. Take this here and write it here. Okay, success, which means that I'm able to resolve this to the ingress of the vault, which we also access through the UI, plus everything else that was put in play is working. That's where I'm able to communicate with Vault. Now, once you are able to use the Vault CLI, it's a never-ending spree, right? You can do whatever it's to be done. So for now, I've just stored a key pair for my username and password. Now, how do you consume this password? I think it's one of the most intriguing topics in the industry today. I mean, there's so many different initiatives and programs happening around. How do you connect to Vault? How do you consume the secrets? How do you? And like I said, we're going to deploy this. This one is basically, coming up from HashiCorp's own backyard, which is called as Vault Secrets Operator. But this one, we are going to deploy it on M2 because that's going to be the client cluster. Okay. So I'm going to make sure that I switch over firstly to my client cluster so that I don't do mistakes of configuring everything on my server cluster, let's say, right? Sorry. Okay, so I'm going to switch my kubectl context to M2. Let me see if I'm able to work with M2. Yeah, I'm on M2. So I'm going to deploy this. I'm going to go to this directory, back to M1 directory, and I'll tell you why, because I need some of the variables to be there inside of this directory, and I'll explain why. So we will deploy firstly the, so we are going to create a namespace called as sock shop. Now this will host all our sock shop application YAMLs and all that manifests. In the same namespace, I can actually do multiple divisive strategies, having a central namespace and then other namespaces consuming secrets from that namespace. For now, I'm just keeping it simple. I'm going to put the operator into the same namespace in which my application will be running. So let's take this and deploy and again, putting the node selector as MD0 so that the controller comes there actually. Standard strategy from. Okay. So this will deploy the operator, secrets operator. This has nothing to do with, Vault as a server or KubeVault as a, wrapper, and nothing to do with KubeDB. It's a separate offering or a, product, let's say that from HashiCorp called as Vault Secrets Operator. We've just installed that. Basically to fetch the secrets. There are 2 ways you can work with the secrets operator. One is through JWTs, JSON Web Tokens, or you can use what's now very popular as the Kubernetes auth method, which is supported by Vault. in this case, we will use the Kubernetes auth method, where you will install a service account and then use those permissions to actually communicate back and forth, okay, in simple layman terms. You can read more about this by visiting their website. Very simple for a single cluster, difficult to understand for a multiple distributed environment. Okay. So for now, like I said, we will first define the service account, which will be used for this particular secrets method. So let's take the service account. While I'm in the directory of M1, I am still working with M2 cluster. Okay, so all this is happening on M2 cluster, not on M1 cluster, although I'm in the directory. So I'm creating a service account in M2 cluster in the namespace called as sock shop. Okay, and with that, whatever remaining goes on, typically ensuring my service account has the appropriate privileges, I will create this service account. Okay. Now, once the service account is created, I'm going to get the secret for that particular service account. And you can see as of now, the files in this are CACRT, key, license, TLS. So I'm going to store that particular whatever variables into this particular directory itself. Okay. So you will see, and these are basically the client kube CA cert, client kube host, and the client token review JW. So these are the credentials associated with that particular service account that we just created in the M2 cluster. Now that we have all of this, we will configure basically the auth type, which is basically I will use the Vault CLI, which is already connected, authenticated, to enable a path BSO and the authentication type for that set to Kubernetes, which means then I should be able to supply the required token and the necessary cert and things like that to this particular config for the Kubernetes authentication type, and then instill a role associated and things like that. Okay. Now let's take this set of commands. Okay, and paste them here. This is basically talking to Vault through the Vault CLI. So you can see that for all three of them, it's a success, which means that the authentication type for the connection is set to auth. The role is also defined here basically. Now, by assuming this role, we can get access to the secret that we just kind of issued actually. Now you can see there the token policies associated are DB creds RO, which means I can read that particular DB creds, which was stored in the form of root and fake password. Now that we have this, there is a way to retrieve this particular. So we have now, let's just summarize the KubeVault operator, a Vault server on M1. And this is already configured with certain inputs in terms of policies, role, and auth type, which ensures that a cluster called as M2 with the privileges of a service account configured here can talk through the secrets operator to the Vault server here. Okay, our kubectl is still talking to M2. Okay, so I'm going to create what is called as a Vault connection. What is a Vault connection? Basically, it's the address of the KubeVault server. And then by virtue of this connection, I'm going to also supply an auth method to this particular KubeVault. And then I'm going to assume this particular role. Okay. You can read more about this on the secrets operators site. So for now, by virtue of these two, I should be able to authenticate my secrets operator with my KubeVault server. Okay, now we will take this and paste it here. So on my M2 cluster, you can see that the Vault connection is created, the Vault authentication is created. Now, what good is all this if it does not allow me to retrieve the secrets? So if I look at kubectl get secrets -n sock shop, I don't see, other than these three, any other secret. But I need that secret that has or contains my root and fake password as the username and password, which is stored in Vault, which now I have a third resource to be defined as what is called as a Vault secret, static secrets. So it can be either a dynamic secret or a static secret. And Vault secret operator itself is in a beta status. I'm not sure of the current one, but last I remember it was beta. So there is some labeling constraint, and I think they're just working it up. But for now, we will make sure that for every database, and it's a best practice too, we will create a separate instance of this Vault static secret. Okay, which means all in all, we will create in what is stored inside of Vault is just a single instance of that. Yeah, but when receiving, we have the ability to create multiple secrets from that one single secret that is actually retrieved. Okay, that gives us the permissions or the flexibility to play with local secrets management on the cluster where their secrets are required. Okay, now we are going to create 1, 2, 3, 4, 5 secrets. And why 5 secrets? Catalog DB, orders DB, user DB, cards DB, and session DB. So 5 secrets. Once these secrets have been created, we will just patch the secret name, the label, one of the labels actually, so that this attests to the CRD type, which will be, in this case, all about KubeDB CRD, so that I can do what is called as an app binding. A successful app binding between the secrets operator or the static secrets produced by secrets operator and the applications deployed by KubeDB, which are MySQL instances, MongoDB instances, Redis. They have a certain linkage that will be created in the backend, and that is called as app binding. And then to facilitate that, we will actually cross-reference these labels, and we are just going to kind of override. Pretty simple. At the look of it, in the backend, a lot of engineering and good orchestration done by all the teams involved here, KubeDB, HashiCorp. So let's take this and paste them here. Hey, that's okay. It takes time, so I will have to just repeat. I did it in a hurry. Sorry, my apologies. I think this is what happens when you are into a call for a long time. Let's just wait for the secrets to come up, and I will just repeat those patch commands. So now if I see kubectl get secret -n sock shop,
I think the spelling, you're missing it here.
So now you can see that outside of those 3 secrets that we initially had, we have 1, 2, 3, 4, 5. And this is what we expected of this whole configuration. You have dynamically populated a namespace based on the secrets stored in, and you have manifested the whole sequence in a way that your 1 secret turns into 5 secrets. So that's pretty plain and simple. Now, the interesting part is why we will not do it here. You could see it on their website from HashiCorp. If I change the secret in the source, which is in the Vault server, every 10 seconds, there is a lookout happening, or a watchdog is running within the secrets operator, which will be monitoring the state of the source secret. If that changes, there's a downstream cascading of those, and immediately the secrets will be rotated here too. And then the secrets operator also has the facility not only to change the secrets dynamically based on the upstream rotation, but also to restart the pods which are actually using those secrets. That's a very interesting piece, because if you change the secrets, somebody has to orchestrate the redeployment of the applications. So you can configure your target deployments. I've not done it here, but you can configure your target deployments to the extent that secrets operator will watch out for those named references to the targeted deployments. And then if your secrets are changed, the downstream secrets are also rotated and the deployments also restarted, so that these they come into effect immediately. So for now, if you understand, as of this state, we have demonstrated the first capability from apps code, which is KubeVault, in association with secrets operator from HashiCorp. We will take a pause on this video, and in the next video, we will move on to KubeDB as the second product from apps code. Thank you. Thanks, Tamal.